I will go to toilet.
Yeah. Oh, okay. Yeah.
That's okay.
Let me take something. Saya Bu. Iya Bu. Saya otomatisin bisa masuk Bu.
Masuk. Terima kasih.
Oke.
Okay.
Haven't sent screen yet.
So how long will be the presentation? 3 hours? 4 hours? Okay.
Okay. Good morning, everyone who are attended this seminar offline or either online on Zoom room. Thank you for Professor from University. We are very happy that this morning we are with you. We are going to attend this presentation from the Zoom, like exploring the efforts for the unification of government service in the specimen. And actually, for the children, as I visited our department years ago, and this time during this holiday, actually in Indonesia, we have seminar, and we hope we can follow the source for the mission of the future with thank you for this meeting and now I'm part of
Thank you very much, Pak Asep, and yeah, welcome back again, Professor Chung, to
This department. I think we met 2 years ago, yeah, before this pandemic, and we discussed a lot of things. But now,
yeah, we come directly to what you will share with us. It is very interesting. Based from the title, we can see that, yeah, Professor Chung is from Analytical Spectroscopy Lab. So there's a lot of analytical methods that will be shown in this presentation, and then I think the students will also learn a lot. That yeah, probably we don't have the method here yet in our department, but then later, yeah, they can get familiar with the methods. And also more interesting is this is yeah, the sample is from biology specimen, yeah, and then yeah, as the treatment also maybe will be very sophisticated and also more than what we usually use in analytical lab, yeah, just for the metals and gas and etc. Okay, without further ado, I think I will give the time to Professor Chung, about 45 minutes, yeah, Prof. Ivandini, yeah,
Okay.
to share this. Please, Professor Chung, thank you.
Okay, thank you for the introduction. Okay, so as she said, that my name is Hail Chung. So this is Korean letter. Okay, so actually, as you can see here, I think that today I'm going to talk about some diverse analytical methods for identifying gallbladder cancer. You know, so I don't know about the gallbladder in Indonesian, but when I was young, maybe 30 years ago, 40 years ago, gallbladder cancer was very, very rare in Korea, because at the time, you know, the economic situation in Korea was not that hot. But as the economy is going on, okay, I think that the eating habit is become more westernized. We eat more beef, pork, whatever, and eat a lot. So gallbladder cancer is increasing. Okay, and also you know the bile, yeah, bile. Okay, so you know, as I mentioned before, I think the one difficult thing is gallbladder cancer is survival rate is very, very low. Okay, yeah. So if you diagnosed as a gallbladder cancer, normally the symptom, you know, normally symptom is not severe. If severe, you go hospital, right? And then doctor examine many things. But the gallbladder cancer case, I think symptom is indigestion. You know, the indigestion, stomach is uncomfortable. Yeah, and normally you feel sometimes, right? So because the symptom is too very not severe, I think normally we find out that the late stage, okay? So there is a problem. And conventionally, you know, the sonography or CT is a conventional case, okay? But this is a visual basis, actually looking for the image, right? So if the cancer is very small, I think it is difficult to be detected by image. Yeah. So I don't know. I think we need to have some more different method. Okay. But you know, gallbladder is not easy specimen. I mean, in the hospital, right? And the urine, very easy. Yeah, okay. Blood is okay. Blood is okay. But if you want to take, the bile juice, it's not usual, right? It is not usual. But also same in Korea, you know the gallstone.
Yes, yeah.
Gallstone, okay? Yeah. Gallstone is increasing, right? Yeah. So if you have a patient of gallstone, we can get bile juice during the operation. At that time, maybe we can use the bile juice as a specimen for the diagnosis. So many researchers using urine sample and blood sample as a diagnosis. Okay. But also in our case, bile juice is a specimen. Okay. So I talked with Professor Ivandini in this morning. I guess your hospital built already, right? New one, right? So if the hospital is very close, it is a very good advantage to taking specimens. Yeah. So maybe there might be the good future. That's why I choose this topic of my presentation. So, okay. So, but you know that, the human bile or bile juice is, bile is secreted in liver and stored in gallbladder and then play important role in the lipid digestion. Okay. Okay. So if you look at the chemically, what is the composer of the bile juice? 85% is water. And the remaining 15%, out of 50%, bile salt is a major one, 61%. And the fatty acid, cholesterol, proteins, phospholipid, and bilirubin, or something like that. Okay. So the basic assumption is that if you have a cancer, hopefully composition of these guys will be changing somehow. Then we can recognize you have cancer or not. Okay. So that is the main goal of our research. Okay. So because Professor Ivandini is also analytical division, so I want to use many different methods. Okay, so basically four. We focus four. First one is infrared. Infrared. Okay, so IR or near IR. Okay, infrared. Usually IR and near IR very easy to measure. Okay, this is one of them. Also, the other Raman spectroscopy. Raman spectroscopy. I will talk about detail, and the source is a surface enhanced Raman scattering. Okay, and also recently many people want to identify disease from the exosome. Exosome is extra vehicles we can extract. Okay, so we can use exosome as a specimen also. Okay, so these two are vibrational spectroscopy, and also the other one is a mass spectroscopy. Okay, so actually those two fields I'm collaborating, not my from research group. Okay, and so also we are working with the proteomics. Is there any special protein if you have cancer? Okay, so actually they analyzing the bile juice to what kind of proteins are present in the normal sample and the cancer sample. So right now we find out that about 10 proteins are uniquely present in the cancer sample, something like that. Okay. Okay, this is a mass spectrometry based on proteomics, And also the other one is LCMS. LCMS is, we separating each individual component and we determine the concentration. Okay. Also, this is a PSI, is a paper spray ionization mass. Okay. It's another mass technique, and you have a paper with the triangle, and you drop the sample, and you add water, and then bile juice is moving, right, in the paper. And when the sample come to etch, and then we have ionization, and we are collecting the mass. Okay, so that is one part of mass spectrometry. And the last part is atomic spectroscopy, not only organic compound. Okay, some case, the inorganic methods are related with diseases, right? So in that case, we use the LIPS. LIPS is a laser induced to break down spectroscopy. I will go for details. So basically, using bile juice, we try to use many different techniques. Hopefully, in the future, we try to combine all of these data, and then using the big data analysis approach, and hopefully we can increase the accuracy of diagnosis. Okay, so that is a major goal, but it needs a long time. Okay, so from now I'm going to talk about each individual result. Okay, so first I'm going to talk about source. Have you heard about source? Yeah. Sure. Raman spectroscopy is not a sensitive technique. Okay. Raman, if you want to detect something using Raman spectroscopy, I think minimum concentration should be greater than 0.5%. Okay, but it's bad point of Raman. But if you are going to use a source, sensitivity is getting higher. But anyway, you need to have a substrate. Okay, very nano gold nano structure or something like that. Let's say this is a gold nano structure. If the molecule attach and then source signal is increasing, that is source. Okay, and also we develop many different sources. Okay, I'm not going to go detail, but anyway, this is actually a same image of gold nanodendrite. So this is kind of electrode deposition. Okay, so actually we purchase a screen printed electrode. Screen printed electrode is very cheap, and we grow those structure. Okay, this is a 5 micron size. This is 20 micron. This is 1 millimeter. So actually, after we building gold nanostructure, you can see the color has been changed, right? Color has been changed, right? And then we measure the bile sample. P is polyp. Yeah, here, P is polyp. You can see the sample, polyp. Polyp is before cancer. So polyp is not always going to cancer. Polyp maybe just sometimes.
Like more,
Yeah, polyp.
more,
It may be tumor, it may be not. Okay. So polyp is a little bit aggregation of the cell. So it may be developing for the cancer, or it just aggregate of cells. Okay. So actually, at the beginning, we have only 10 samples of the polyp and 4 samples of what? Of cancer, and we measure Raman source. Okay. And then this is the source signal. Let's say if you add a sample, there is no Raman signal on SPE. But if you have nanostructure on the SPE, you can see there are very strong Raman peak. But I think the most disadvantage of source is the source. To make a source, molecule should be attached to the surface. Okay, so normally source active materials are compound contain nitrogen or sulfur. Okay, so but like I mentioned before, in the bile salt, there are many different components, but among them only several components can be source active. That's the bad news of source. But sensitivity is very high. Okay, so actually, when we have this signal, I think it takes us 6 months to what compound is responsible for this one. In this presentation, I'm talking about only 20 seconds, anyway, we found out that this is from the bilirubin. This peak is bilirubin. Okay, so bilirubin structure, there are 4 chiral rings. Okay, so very easy to attach the gold surface and Raman signal. Okay, and then we measure the Raman signal and we run the PCA. The PCA. PCA is very popular principal component analysis, and spectrum is very long data, right? But the PCA is representing data as a very simple X and Y, 2-dimensional dimension. So the polyp and cancer is not really differentiating. Okay. So I was unhappy, but anyway, if you apply the voltage, maybe she may be expert. If you apply the voltage, I think the adsorbed material, the molecular behavior might be different. Okay. So actually, that's why we use a screen printed electrode. We measure the Raman. At 6 different voltage. Okay, -300 to +300 volt. But if you're looking at that, when you apply -100 millivolt, I think the cancer and polyp separated. Okay. So it was very hard time to take why Why is that? Also, bilirubin has many derivatives. Okay, urobilinogen, urobilin, stercobilin. There are many derivatives of bilirubin. Okay, and you can say that, you know, that one, urobilinogen. Okay. So maybe if you read this one, I think a previous study reported the level of fecal. You know the fecal, right? Okay. I don't want to talk detail. Okay. Fecal urobilinogen was higher in colon cancer. Huh? Higher in colon cancer. This is a previous study. So actually, this is a CV. She's expert. CV of bilirubin. We have oxidation peak. Okay, but when we measure the bilirubin, when we measure the urobilinogen, there is no redox peak. So I talked with the electrochemist in Korea. There is no redox process. Maybe we can infer chemical reversible coupled with proton coupled electron transfer process. So that means that the urobilinogen, if we apply minus 100 voltage, I think it attach surface much stronger. You know, the surface signal is increasing if you attach more and more stronger, and the surface signal is increasing. So to prove that, this is a Raman signal of only urobilinogen, only, not bile juice, only urobilinogen, and the minus 100 millivolt Raman signal is only increasing. Okay, that's why we have a separation here. Okay, so anyway, so this is a beginning study at the moment, and also we try to go for a little bit more practical measurement. Is that this is another source substrate, okay, and this is a nickel foam. You know the nickel foam? It's like a sponge, but very strong, okay, nickel foam. And inside the nickel foam cage, we make a silver gold nanostructure, okay, silver gold nanostructure, and then we scratch 100 times on the sandpaper, but still Raman signal is very stable because nickel foam is very strong material. And also we sonicate substrate 30 minutes, but still signal is decreasing only 12%. And also we just exposed to air about 25 days. Such signal is quite okay. Okay, so this is an earlier report there. Okay, and then we use this one as a like a online platform. Okay, so basically this is a filter paper. This is filter paper in the chemistry lab. We cut like this. And we put nickel foam with the gold silver structure. So this is going to be bridge, and this is a bile juice, and we drop the sample here, and water is bring those bile juice to bring here. Okay, and then when the analyte is moving this nickel foam, source active material will be caught, and then we shine the laser here, and we measure the Raman. Okay. But to be honest with you, this is a very interesting approach, but I don't know, it can be really applicable or not. Okay. But anyway, we measure naphthalene thiol, bilirubin, whatever, blah blah. Also, this is a very good. This is the biggest one is bilirubin. The small Raman peak is the other component, bile salt, whatever. So as I mentioned before, if you have nitrogen or sulfur in your group, search signal is very high. The other component, the search signal is very low. You can see the you know, this is about 1200. This is about 20,000. Okay, so bilirubin is much bigger. Okay. So anyway, so I'm gonna skip this one. Okay. So we are little bit disappointing at this moment. I mean, we published the paper, but anyway, a practical viewpoint, because the Raman is what? Only, let's say we are the bile component, okay? But I mentioned before, Raman special source is only, we can looking only nitrogen sulfur containing compound. How about the other components? The other components may be indicative of disease, but the search cannot look at all of the signatures, right? So why don't we go for the NIR spectroscopy, which is looking for all the components, okay? And actually, we start with separation, okay? So I'm going into detail, but this is a organic phase. This is chloroform and water and methanol. And this is organic phase. This is the aqueous phase. In the middle, here is aggregates. So aggregate is a protein, amphiphilic. So actually we separate three phases, okay? Three phases, and then as you can see here, we have more population right now. Yeah, normal. So bile juice, getting a normal sample is very difficult. Because normal people, they don't want to take out the. So this is normal sample is from the organ donor. So it is very hard to get. So normal gallbladder polyp. HC is a conventional liver cancer. And gallbladder cancer. Right now, 4 samples good. Okay, and as I mentioned before, we separate it into 3 phases. Okay, and then this is the NIR spectra of amphiphilic aggregates. It's a protein. Okay, I mentioned that 3 phases, right? I'm talking about the first phases, and then this is a general NIR spectra, and this is a different spectra against the normal. So if you look at the different spectra, GB cancer compared to HCC I mentioned it's a liver cancer, GB polyp, those two are quite similar. GB cancer is quite different. Okay, and then as you can see here, you know, green one is GB cancer. We have a little bit separation, but not clear. Okay, and also aqueous phase. Aqueous phase is taking a lot of bile salt, glycolate. There are many abbreviations. You know, cholesterol plus, you know, salt, bile salt. Okay, there are, as I mentioned before, in the bile juice, bile salt concentration is highest. Okay, so in the aqueous phase, because these are salt, they are present in the aqueous phase. Okay, this we measure the pure spectra of those. Okay. And we collect the NIR spectra again. Also, this is a synthetic sample. Normally, taurine conjugate, G means glycine conjugate, the ratio is 3:1. So we make a synthetic spectrum like this. Overall spectral features are quite similar. Okay. And also, we examine that GB cancer different spectrum against the normal. You can see GB cancer different spectrum is a lot different from those two. And we run the PCA. We run the PCA like this, okay? We have a little bit separation, but not clear, okay? And also this is a bile salt concentration measured by LCMS, not NIR, okay? And you can see all bile salt concentrations are low in the GB cancer. Okay, you know, so bile salt concentration in GB cancer sample is low. So this is a measure. This is measured by the LCMS. Okay. So why is that? I think the main reason is that this is a kind of, the protein, cyclooxygenase 2, okay? This is a cell protein, okay? It is increasing in GB cancer patient. So if this protein is overexpressed, the wall of gallbladder is getting thicker, okay? So wall of gallbladder is getting thicker. That means that water absorption ability is decreasing. So GB cancer patient case, they cannot absorb the water efficiently. That means the more water, that means the dilution of your bile juice. That's why we have all bile salt low concentration. Okay, so there's the main reason. Okay, but nonetheless, the green one is not completely separate. Okay. And also, this is NIR Spectra of organic phase. Organic phase, what? Lipid, right? So the major one is phosphatidylcholines and the phosphatidylethanol Usually they say PCs and PE. And 34 means length of chain. And one is the position of a double bond. Okay. Okay. So 30 to 4, something like that. And also we measure. This is a pure component, NIR Spectra. This is NIR Spectra measured from the real bile juice. And if you look at the different spectrum against normal, in this case, GB cancer is a lot different compared to HCC and GB polyp. Okay, a lot different. Okay, so also we measure the concentration of a PC and the PC. Okay, different PC, right? Longer chain, number of double bond is 1. Number of double bond is 2, 36.2, 36.4, PC 36.6. Right? As I mentioned before, also in this case, in the cancer case, the concentration is low because of dilution. So due to this reason, you can see we have a good separation. We have a good separation of GB cancer. So right now we have very, very hard homework left. Why these PCs are different, a lot different. Okay, so that is a case of IR case. Okay, so I'm gonna skip. We analyzed another fatty acid by LCMS whatever. Okay, so because of limit of time, I guess I'm gonna skip this one. And the next is LIPS. LIPS is laser-induced breakdown spectroscopy. Okay, it is very fast. You shoot the laser, and you make atomic ionization, and you have a peak. So LIPS peak is very, very sharp because LIPS is very sharp. This is a typical LIPS peak. Okay, atomic emission is very, very sharp peak, right? So for LIPS measurement, we use the laser patterned silicon substrate. Okay, so we make a pattern. Like this pattern. Why? Because if you drop the sample, in the clean surface, you have a droplet, and if you dry the bile juice, the outside is thicker. Usually we call the coffee ring effect. Okay. So, but in this case, when we drop the bile juice on this substrate, the bile juice spread out homogeneously. Okay. And also we use the lithium. We use the lithium add as an internal standard. And the LIPS peak is shooting the laser. Maybe signal absolute intensity may be changing. And then that's why we put the LIPS peak. And using the LIPS peak and the relative standard deviation of each measurement is not bad. 5.1% or 7.2%, something like that. Okay. So and then this is a LIPS spectra. Yeah, in the biological sample, Most dominant one is sodium, calcium, potassium, and magnesium. Okay, this is typical. Even you measure the blood, same.
You don't have iron? No.
Not many iron. Okay, okay. And this is a magnified image. Magnesium, calcium, sodium, potassium. Yeah. But you know, GB cancer is blue color, right? And you can see the shade. Shade is variation. Shade is a variation of all the samples. You can see the blue one is lower, right? Why is that? Dilution. Because you know, GB cancer bile juice, you know, the water concentration is higher. So dilution, also metal concentration is lower. Okay. So actually, this is a peak area of magnesium, calcium, sodium, potassium. You can see always blue one, blue means the GB cancer is lower. Okay. But this is also another plot making a peak area ratio. This is absolute magnitude. This is a ratio, okay? But you can say, if you can take a ratio and sodium and potassium, clearly different, okay? So this is there are many papers. Sodium potassium ratio is quite indicative of cancer. Okay, so that's why I'm 55 years old. Actually, my birthday was 2 days ago. Okay, so actually, when you are getting old, and the doctor asks to eat more potassium. Yeah. So sodium, potassium. So actually, if we take out blood, and the young student, sodium and potassium ratio is lower than older people. Okay, so try to eat the potassium. Okay, okay. So banana is good. Banana is good. Okay, so lips is also. So there is some differentiation. Okay, okay. And also, you know, let's say I talk with the source. I talk with the what? IR. I talk with the lips, okay? What is the scenario? Scenario means in IR case, you have to, as I mentioned before, we have to extract the sample, right? It takes a time. In hospital, people, they don't want to do that. Yeah, they don't want to do that. And also, especially if you have a hospital, if you have a solvent, and no, they don't like it. So, but in IR case, search case, we need to extract the sample. So practical viewpoint is no good. Lips is good because we measure the raw bile juice directly. Okay, but no, not directly, but we dilute a little bit. But dilution is okay. Dilution is okay. Dilution, okay. But NIR, you know the NIR? NIR is very low absorptivity. That means that, let's say, if you measure the IR spectroscopy transmission, it should be very thin, like a polymer film right there. But NIR, molar absorptivity, is very low. You can measure thick sample, okay? So NIR might be good. So also, you can see right now, we add gallstone. We add gallstone right now. Right now, 5 groups, okay? And then, very simple. This is Teflon, just Teflon. Teflon plate. Teflon does not absorb NIR. Okay, Teflon does not absorb NIR. Also, Teflon is very hydrophobic. Very hydrophobic. So if you drop the bile juice, this is a real raw bile juice. If you drop the sample, it has a very beautiful hemisphere. Yeah, and we dry. And we measure the NIR radiation. Why? To cover the whole cover the whole what? Whole dry bile juice. Okay. Okay, so and then this is the NIR spectra of 5 different groups. Okay, 5 different groups. And then we have this one is a ratio of those 2 peaks, and this one is a ratio of those 2 peaks. You can see, and what? In the GB cancer case, ratio is a little bit different, not complete, but not completely different. Okay. And you can see this is the first, the second score. Still, cancer is not difficult to differentiate. Well, it looks bad, but we have a little bit separation over here. Okay. To increase selectivity of NIR, we use the 2D correlation analysis. Okay, I'm not going to go detail. Okay, 2D correlation analysis is we have 2 spectra compared together and enhance the different spectral features. Okay, so as you can see here, if you have a correlation map, normal gallstone polyp HCC, correlation map pattern is quite similar, right? But in the GB cancer case, somehow different. Okay. So it informs that the spectral feature of NIR obtained from the cancer sample somehow different. Okay. So this is using the 2D slide spectra. We run the PCA again. As you can see here, we have a better separation. Okay. So actually, I told Professor Ivandani in this afternoon, I have 10 more years to retire. Okay. So this is a feasibility study. Okay. So I talked with the doctor. He is 2 years younger than me. So we try to collect about the bile juice about at least more than 5 years. Then we're going to have a lot of database. Maybe separation might be not good, but we can use many AI bases, feature selection or deep learning or whatever. So NIR is most practical because as I showed you before, right? You just drop and you just try and you measure the NIR spectra. Okay. So we're trying to increase the number of subjects up to about 1,000 over 5 to 10 years. And maybe before retirement, I'm going to bring this data with a lot of people, see what happens. Okay. See what happens. But if it is possible, I think NIR is very practical. Very practical. So NIR instrumentation is not expensive. NIR instrumentation is not water sensitive. Just easy to maintain. Okay. Even non-specialists, they can measure. Yeah. So this is NIR result. Okay. Okay. And also, I think this is a last part of that. I'm going to. This is also hopefully also hospital applicable technology. In Korea, there are many hospitals. They already have a mass spectrometer. Okay. But in this case, this is a sample. Okay. This is just filter paper. And actually, they drop the sample. You see, color is a little bit different, right? And then if you add, but in this case, you have to dilute. But dilution is okay. Okay. So 1 microliter biosample diluted 10 times with 30% acetonitrile. Okay. And then solvent methanol, and they are moving. And when the sample is moving to here, and they ionize sample, and they measure, they can collect the mass spectrum. Okay. Okay. So actually, this is a mass spectra. I'm not a specialist of mass, so I don't want to go detail, but mass is powerful, right? Mass is powerful. They can have a whole different molecular peaks, like You look what, bisalt, different bisalt, whatever. There are a whole bunch of information, But as I mentioned before, the measurement is quite easy. Just dilution, and you drop the triangular filter paper, and you can get mass spectrum. But I don't know, this mass intensity is quantitative or not. It may not be very quantitative. Okay. So also there is assignment. Okay, LISO PC, mass spectrum. They identify real virus. Also, they have a 478 peak. This is standard peak. This is a virus peak. Okay, so it is clear this compound, LISO PC 16-0, is inside the virus. Okay, and also we have the same analysis, and there are some difference in the mass intensity, whatever. Okay, so this is actually we have that one, and also I mentioned before the paper spray ionization, PSI, paper spray ionization. I said that peak may not be quantitative, right? May not be quantitative means maybe depends on measurement. Some same sample intensity is higher, intensity might be lower, something like that. That is really bad for the quantitative analysis, right? But if you take a ratio, of two peaks, I think instrumental variation can be compensated, right? So when we have a PC32-1, PC32, like IR case, quite different, okay? And also PC34, 34-2, 38-6, the difference is quite good, okay? So potentially, I'm working with my colleague, potentially this PSI mass might be applicable in the future. So I promise we're going to collect 5 more years, 5 more years, and increase the number of samples and see what happens. But because we are in chemistry, I'm trying to show some different techniques to analyze the biology. So hopefully this can be helpful, especially for the students. Okay. So this is also current research, okay? And also, actually, we have a published paper, this one, okay? And why not? Why not having only one data? Why don't we combine together? So actually, this is a LIPS and NIR. I mentioned before, LIPS, we can measure raw biojuice, right? We can measure the raw biojuice without any pre-treatment, okay? So also NIR, we can measure the biojuice directly. So why don't we combine two techniques, which is not necessary pre-treatment? And also, beautiful thing is atomic information, molecular information, maybe can be synergy, okay? So we combine the LIPS information and NIR data, and we have a better separation. Also, wait 5 years more, okay? Okay. And also we trying to use source measurement, okay? Indirect source means you have a source substrate, okay? You have a self-assembled monolayer. You heard many times, yeah? When you make a self-assembled monolayer, you are going to use a thiol, right? So we have a thiol coverage on the surface, okay? Thiol coverage on the surface, but on the terminal, in the terminal, we are going to use a different functional group: methyl, amine, carboxylic, and hydroxyl. So if bile components in biojuice interact with those 4, the interaction might be different, right? So Raman signal is different. So why don't we combine all the 4 Raman signal, and then we have a possibility of separation. So that's why I said indirect source. Direct source, as I mentioned before, we can only recognize the bilirubin related compounds. Okay, But in this case, we can recognize the other components, but recognizing is indirect recognition. But we try to use different functional groups. Okay, so when we combine together, this one. Actually, this one has been published also. This one is published. I didn't put on the references here. Also, this is more like an academic study, exosome. Exosome. Okay, exosome is extracellular beakers. Okay, so exosome is recently drawing attention. Maybe that sample can be disease indicated. Okay, so we try to measure exosome and also proteomics. Proteomics. Okay, proteomics. I think I don't know if we have a very specific protein only present in the bile juice. If we can find the protein only bile juice of cancer patient, we can make a kit. Yeah, you know, like a COVID test, right? So let's say one protein is only present in the cancer patient. We have antibody like a pregnancy test, a COVID test. Okay, so we try to find out very specific protein which are only present in the bile juice of cancer patients. Okay, so many spectroscopic technique, bioanalysis, something like that. Okay, so I mean, this is a final conclusion is that I think we have only we are using only one same sample, but many different approach can be tried, and hopefully all the combination of those data will be helpful. But I don't know. But personally, practical viewpoint, NIR leaves combination is very good. I think a very potential because it's simple and easy. And also, hopefully, if I'm lucky, if we find a very specific protein, maybe we can make a company. Yeah, we can make a company like a COVID test or something. Yeah, like make a kit, right? Okay. Okay, I think I control the time. Okay, so thank you for attending the seminar. If you have questions, please ask me.
Yeah.
Thank you very much. Terima kasih.
Okay, let's give round of applause to Professor Chung. Yeah, very interesting and inspiring talk somehow. Yeah, we learn. I think here we already familiar with IR Spectra and LCMS, sure, and then SIRS, Raman, yeah. But then for lips and proteomics, maybe for bio.
Chemistry students are familiar the lips of for us. That's what ablation.
Yeah, it's a laser ablation technique. Laser ablation technique. Yeah.
Okay, now we come to question and answer. Perhaps we start with the students here first. If you have a question, please give your name and also
Okay, hello, my name is Melody. Actually, I have emailed you like a few months ago.
That's you. Okay.
So, hello,
Okay.
and I would like to say thank you for the presentation. Really, it's really impressive. There's a lot of NIR method. This is my project for the.
Yeah.
So my question is, you mentioned before that as the substrate of the NIR, using FPV, and FPV, modified by both religions.
Yeah.
Actually, as my project, I try to synthesize the both religions, but experience. So the question is it possible if we change the using the nanostructure to and use the same detection method for the carbon. Or maybe we use like, or maybe this kind of using NPC with the carbon electrodes modified by local structure. Is it possible to use detection of the molecules, whether it's the result is good or bad? Is it still possible?
I think the other nanostructure, if you can build on the SPE, the other nanostructure is working fine, but sensitivity might be different. If you have a more sharp edges, whatever, sensitivity is getting higher. Yeah. Yeah.
Partner, the nanostructure is very important.
Okay.
May affect the vibration of the ramen.
Okay.
So, so it depends on the partner and doctor whether it's both or maybe.
Okay. So basically any kind of nanostructure is working. Okay.
May I have one question?
Okay.
So, the next one is the silver and gold modified the nickel. So, the question is it possible to change the nickel maybe with the copper form?
Yeah, it doesn't matter. But the nickel case, nickel is not source generating material. In this case, nickel is just our bone, just frame, only frame. Okay. Also, if you use a copper is a source active material, but not strong as like a silver and gold. Okay. Also, I have experience that we incorporate copper, silver. No, it's Olympic. Gold, silver, copper together. Yeah.
So maybe the best one is the price of material.
Sure. Yeah. Also, if you are going to using the copper or whatever, also try use not only application for source, also application for the catalyst. Okay, together. So many people they develop some multi-material nanostructure, and they use sometimes the source. They use it sometimes for the catalyst, like methanol oxidation or whatever, something like that. So when you build a nanostructure, try to think about two different applications. Okay. You're welcome. 감사합니다.
As you said that in small scale that work under the business structure of the particle, right? Cells communication. So as you said also that the growth structure having a strong evidence showing a very good signal of the super enhancement technique. But as I was told, different structures of the particle need a lot of structure, right? For example, like CTEC, everything. So it means that when we are making it, that we have to start assembly or making a monolayer, and after that we have to
So that's why in our case, it's not a solution. Not solution based. This is just electrode deposition of gold, gold and silver. So I know if you have a solution basis, I think there are a lot of labor or very sensitive to condition. But in our case, all electrode deposition. So we put SPE on the gold solution, and we apply the voltage and like the electrode deposition with the NIR, iodine or whatever. So, and then we grow the structure. So we don't have that kind of problem. I know that kind of problem. And also, if we want to have gold and silver, okay, maybe we can build the silver electron deposition by silver structure, and we can add gold very easily by galvanic replacement. Very easy. So all of substrate I show in my group is all electrochemical preparation, not the wet chemistry.
That's the benefit of it.
Yeah.
We have that to have that maybe the better signal of cell. We have a strong areas and we know the problem and the challenge for that. We have any solution for that?
Solution case?
Yes.
I don't know. I don't have enough. I'm sorry. I don't have enough experience to answer them. Yeah, I know. I saw many papers, right? Also, maybe I don't know. Are you a student of the Professor Ivandin? No.
No, I visited from Korea.
Oh, really? So visit Korea. Hi, I see. Okay. So, but anyway, solution process. I don't have enough experience to answer your question, I guess. But I know there is a little bit difficulty. Yeah. Okay.
Thank you for the
Okay. 한국말 잘하세요? 정말. 예. I ask, can you speak Korean?
Then there's one in the chat. I will just show you.
text.
In what gallbladder cancer stage, there's these methods can actually be used for the analysis of the biopsy.
But I think that is a tough question. I don't want to answer, I guess. But usually our sample is mostly third and fourth stage, because like I mentioned before, no, because the symptom is not strong. Okay, so the patient, the identification detection cancer was quite late. So we need to have first stage or second stage sample, but it is practically very hard at this moment. Okay, so okay.
The sample of bile, how can we get from hospital?
Yes, in the Hanyang Hospital.
Oh, okay.
In Hanyang Hospital.
Because I cannot imagine how to, so
I think they're using like a long syringe, I guess. Yeah, long syringe.
it's like that you want to take aminoprotic liquid from the pregnant.
Kind of.
Yeah, okay. Okay. Right. I just want to
Patient or this technique that the bit that we want to see the metal compound from using lips, but then also IR like near infrared or IR for the compound. You want to see both sides. But then in cancer, like you have like why you need to see this metal? I mean, yeah.
Because some case the many disease. I think the metal, the certain level of metal is. But yeah, I mean in normal case we need to have a balance, right? So metal induced metabolism. Okay, but if you have a disease, the total metabolism is changing, and the relative concentration of metal is different.
For this, it's straightforward that you can see the metal. About that, so it's like the normal the first member of the but then for this NIR Spectra, this is also for the student. what functional groups that actually specific for the cancer? I mean, that what yeah, what is the range is for example for 4,000 to 4,500 point number, sorry. Yeah. What specific functional groups that actually involved? If you can.
So actually, if we measure only pure compound, I think we can say this is coming from this functional group, something like that. Okay, but the biojuice is complex mixture. That means all the spectral fixtures are mixed together. So not only one specific functional group, many functional groups relate with the disease. So that's why we have to use the multivariate analysis. Yeah, multivariate analysis. Okay.
And then, so at this stage, you only see, no, not only, but then I just guess that in this stage, you just see the differences.
The differences.
Differences.
Also different shapes. Yeah.
It's just like a subtraction from the normal.
Yeah, something like that.
File.
Mm.
Use and compared to.
Okay.
Okay, thank you. Maybe more question? Analytical expert?
Yes, interesting. And you that analysis of the statistic, yeah.
Itu gue punya ATR tapi ATR tuh dia tuh mirip ATR tapi dia nilainya tuh panjang.
You find that the principal component analysis quite separated.
Okay.
Between the cancer, the green one.
Yeah, green one.
Data with the rest of the data. Separately, you see the axis Y, right? The X
and Y.
four. But
Y axis.
Y
Yeah.
type Y.
Yeah, spread, right?
Growth.
Yeah.
Explanation for that.
No, I think X is a first component. First principal component the first principal component is most find the most different signal feature. Okay, so basically, so that means that I think the first component is enough. So actually, I plot two-dimensional, but I think I can drive only x-axis. So then maybe the two group is different like this. Okay. Yeah. Okay.
Yes.
So if we have a chance, student come to Korea. Okay. From 2 days ago, the Korea weather is decreasing. So very comfortable. Yeah. The daytime only 27.
27.
And the night only 20. And the humidity is getting lower. Maybe you experienced that. So usually the best season for me is September. Late September and late October. You can change the color, change of the leaves.
Yeah, for the leaves. Yeah.
And very romantic. Very sad. You have the same feeling with you at the
Okay then. Yeah, if there's no more questions, then we will give round of applause again to Prof. Chung. Thank you very much. And, and there's also like a token appreciation from us, a small token. Yeah, given by head of department. Siapa ya? Enggak. Kasih Bapak ini. Ya, oke. Ya. Tutup.
Another one for 5 years later.
How many students in your working with yes?
Only for this one. Only for this one.
You have made 2 PhD students. Lots of data. Ini jangan dipakai lagi.
Together, take a photo. What?
Ya. Oke, Dan, ya. Yang di Zoom bisa ditutup aja Zoom-nya. Ya. Oke. Terima kasih ya yang sudah hadir di online. Sampai ketemu lagi di kuliah berikutnya. Iren, kau tidak hadir di kelas.